I will talk about many of the stuff, but at a high level. There are a lot of great sessions to go to get to know more of the details. We also have a cool demo that will showcase how all these technologies come together. And finally, when I was looking at the sessions we have put together for the next couple of days, there are so many great deep technology sessions. I thought I'll give you all some pointers to the sessions that pique my interest. Just my opinion. Hopefully you'll find that useful. So let's take it from the top. Bob talked to us about a digital economy. You know, this digital economy is intruding into large swaths of human commerce and human interaction. It is pervasive. How we communicate has changed. I mean, we text, we chat, we Snapchat, we blog, we tweet, we poke, we like, we nudge, yo. If all that is too much work for you, you can just swipe right or left. You know, all this you do before you actually talk to anybody. So that has changed. How we bank, how we buy, all the way down to how we hail the cab has changed. It's no longer looking down the road and waving a cab down, straightforward looking down and waving your thumb. And every time you wave the thumb, data is generated. Where does all this data go? It required a rethink in the digital economy for a data infrastructure. Enter NoSQL systems, and these promised easy scalability to adapt to the varying business requirements, faster response times, and of course, easier way to program to them as well. We at Couchbase have been developing a system for this digital economy, a new data infrastructure. We started with our Couchbase Server. There we had a unique insight based on which we built it. We wanted to build this based on memory and network-centric and not so much the disk-centric architectures that we have all used to in the data infrastructure. So that gives us an easy way to scale, and it also gives us the flexibility of how the system could be used. It could be used as a distributed cache. You just started as a cache. You can get on to being a key value store, and then as a document database. We were also the first ones to build a database, a NoSQL database for mobile devices. We built that ground up. We didn't take the server and try to shrink it down to fit into a mobile device. Just like the mobile OSs were a rethink, Android and iOS and other ones for embedded systems. We built the first NoSQL database for the devices. Then we hooked it up with a sync gateway so we can transport the data from the edge to the cloud, and that is subsumed in the data tier. Otherwise, there were so many solutions for syncing. Everybody had to build it at the app tier. Now you have it at the data tier. That gives us, like Bob talked about, the broad or general purpose database that you could use in the NoSQL ecosystem. Now, if you just pull back and look at how NoSQL is, you know, there are many solutions which are pretty high up on the programmability scale, which are easy to program to. And there are systems which are easy to scale, but are difficult to program to because of rigid data structures and programming models. There is yet to be a system in the NoSQL space which is both easily scalable and easily programmable. And that's what, with Couchbase Server 4.0, we are changing. With Couchbase Server 4.0, you will have a system which is a proven leader in performance and scalability. To that, we are bringing great programmability. How do we achieve that? That's NCL, our query language for JSON. I mean, this is the first time there is a query language for NoSQL systems. NCL brings the flexibility of JSON, which is what programmers really love, and the power of SQL to be a fully expressive language. When I talk about JSON flexibility, What I basically mean is that JSON allows developers to adapt to business needs quickly. If your business need changes, the objects that you're using to program that application changes. And if that object definition changes, then the JSON, which represents the data model for that object, naturally changes. If that's what you're persisting, then that gives you all the flexibility that you need in terms of application development. Other way of putting it is, this is how you remove the object relational impedance mismatch, because what you're programming to in memory is a structure, which is the JSON structure. And if that's what you're storing in the database, it removes certain impedances. So you don't have to have that schema, and changing that schema requiring other stuff you have to take care of in the database. That fluidity of how you develop and how you program to in memory and how the data is stored in the database, if that is in line, it makes lives easier. To that, when I say we bring the power of SQL, you don't need more chaos. You don't need another programming language. You just need more order or structure. So if you add the power of SQL to this, then what you get is a complete expressibility of a language working on a data model that's really flexible. That N1 that you see in Nickel, it's not some science fiction geek chic name that we came up with. It's not R2D2 or C3PO. We didn't want to help George Lucas name his next droid. Right? That N1 comes from relational algebra. It stands for the non-first normal form relational algebra. And basically what we're doing here, the non-first normal form relational algebra basically says that if you have your data definition in the object form, then the data that this object reference could be expressed as a relation within the object as opposed to distributing it over multiple relations. And this is what brings the power of the NoSQL nested recursive description that you have in JSON and the power of SQL into one. So when we looked at this query language, we looked at it pretty deeply to see what do we want to build. And why we liked SQL was basically that it has two great characteristics. One is that it actually extends English. It stops with the what and doesn't get into the how. I think that's the great power of SQL. The second is that it stands on a great mathematical foundation, which gives us the completeness. We know if you choose something like SQL and you apply the algebra correctly, you will not be left up the creek without a paddle. We know how we can manipulate the collection of data that you have, and any relationship you want to establish within that is expressible. It's mathematically complete. So these are the two main characteristics that really drove us to actually adopt SQL and extend SQL to a document model, JSON. When I say extend, what it really means is that, first, it's actually working on a different data model than relational tables and columns, the tuples. It's actually working on a nested recursive object format, which is JSON. In addition, we have also extended SQL with a couple of verbs. One of the important ones is unnest. There are others of array processing and other stuff. I'll just talk about unnest, just to give you a sense of what we had to foundationally change so that we just switched out the internal combustion engine. The rest of the car is just the same. Where the steering is where it is. Where the pedals ought to be, it's where it is. We are not trying to teach people a new system of driving or a new way of operating the car. The internals we have changed. It's like an electric car, if you will. So that plumbing, part of the plumbing is this unnesting. Let me talk about unnest a little bit more in detail. We all know this is the Matryoshka doll, a doll within a doll within a doll. And if you're wondering what's a grown man standing up on stage talking about dolls, it's not about the dolls really silly, it's a recursion. I hope I get your attention with recursion here. So what we do is, using the nested recursion, you get to a state where you're able to pull out the object that you want to program to, and then you can apply the rest of the SQL selection, projection, selection join and projections to it. So that's the power. So what basically does is leaves the data tier concern down to the database. The application developer does not have to get the whole collection, do the unpacking on the client side, on the application tier. That's way slower, always has been. So that is now what will happen in the data tier. That's a great addition. So now the database will do the job it should be doing, which most of the NoSQLs until now haven't been able to do. Now, as programming always is concerned, it's all about encapsulation. We don't want to expose all the stuff to all the developers, right? Developers should be developing in the programming language that they are most comfortable with. And all this, the data tier magic should be hidden, encapsulated. So what we have done is to have integrations with or language bindings with the appropriate infrastructure in programming languages. Like in the case of Java, we have Spring embedding. For .NET, we have Link. And for Node.js, Ottoman. So it allows developers who want to just work in relationships between objects to continue to do that. You do not have to get to the SQL tier. But if you want to express something in SQL, even there we have language DSLs, domain-specific language extensions within this, so it becomes easy for you to express that. You can get to that when you need it. Otherwise, you simply map your object relations, and there is a ODM tier equivalent of like a ORM that will take care of this mapping. There's another benefit of SQL, which is the ecosystem. So this basically brings all the other tooling, be it BI tools, reporting tools, visualization tools, all this tooling now seamlessly works with data that is sitting in Couchbase. That's a huge benefit. You already have trained workforce which knows how to operate these great tools, very sophisticated tools. The data that is sitting in Couchbase naturally plugs into their pipeline. So Metanautics, Informatica, Looker, Microsoft Excel, Tableau, we have a demo using that. All these tools naturally, you will see no difference. You'll basically go choose a data source. Traditionally, you've only chosen relational databases. Now, Couchbase just naturally is another data source that you can plug in, introspect that, play with the data that is sitting in there, and combine that with the rest of the pipelining that's been developed. So this is another great benefit. So it brings in a lot more developers. So far, NoSQL systems were sort of something that only developers could look at introspect. Every time I want to look something, I'd write a program and go look into the data. Now, actually, you can introspect the data because of all this tooling coming into play here. I've talked a lot in terms of the query language and the programming ease. But at the end of the day, it's about responsive applications. If all this magic finally leads you to a point of more frustration or slower application, doesn't really cut it. So we know how to solve that problem. The server has to solve the problem in the back end. We built a secondary indexing infrastructure to solve that. And there are two main problems to solve here. One is performance. The other is scalability. Let's talk about performance first. So far, the indexing problem is solved with binary trees and B+ trees. They were logically hitting some of the physical limits of the system because of the data shape changing. The data you want to index are much longer now. It could be blogs and tweets and all that stuff. So basically, it was hitting block limits, and the velocity of the data that is coming in basically makes it those binary trees way taller. So getting to the data was getting slower. That was the problem. The B tree structure was getting, well, let's say the tree had to be pruned. So what we thought about, when we thought about this problem, what we came up to build was a new way of indexing this data, which is built on a foundational principle called hierarchical B+ tries. So every node here is a trie. That's what the 3 inside of a triangle is represented. what this basically does is it, like I said, prunes the tree, makes the tree less taller and it makes it more compact at the end of the day. So the tree height and the compact nature of the data storage leads to two things. You get lesser hops to get to the data you want, and then you have less disk fetches because it doesn't span too many disk blocks and boundaries. Both these things give us the performance we are looking for. And just to convince ourselves that we really had done this right, we actually looked into comparisons of various key value storage engines that are sitting out there. LevelDB, RocksDB, WiredTiger, there are some great ones that are out there. And no matter how we sliced and diced this, in certain mixed load performances, we looked at write amplification, latency, throughput, reads, initial load. There's so many parameters we looked at. I'm just giving you one sense of it, which is like a mixed workload where you have reads and writes happening at the same time. And depending upon how many threads you spawn, you can basically see that it can be anywhere between 2 to 8x performance differential. The same numbers you see in our write amplifications, and that's also a significant point here because the write amplification, what it finally does is that you're actually going to hit your physical media that many more times if you have less of that, especially in the case of SSDs. The lifespan of that is longer now. And this is, the FORESTDB system is fitted for SSDs because it's what is known as a tail-append architecture, which naturally fits into the way SSDs read and write data, which is very different from spindle disks. So that's performance. We have solved the performance problem by actually rethinking how we want to store our indexes, which still leaves the problem of scalability. Let me illustrate scalability with an example. Let's say you went to the library looking for a book, let's say Dan Brown's Inferno, and assume that somehow in the library, the index cards for the books are stored next to each other. Right? That's how databases store indexes and data. Index and data are co-located. They are next to each other. So imagine if I walked up to the library assistant and asked them for this book, Dan Brown's Inferno. If this is how it was stored, what you would basically have to do is that the library assistant will have to take you for a little walk across all the 5 floors of your library and then say, oh, here is the index card, and here is the book right next to it. Here is the book you're looking for. But that's not how we do this in real life. I think we've gotten smarter. What you normally see is that when you go up to the library assistant, they'll turn around, pull out a drawer of index cards, go through that, B, Dan Brown, okay, here's Inferno. And there's a Dewey Decimal System and says, oh, go to the 2nd floor, fiction section, 3rd rack, 2nd shelf. You can go there and pick up the book. The insight from this is that indexes need to be centralized and data can be distributed. And that insight led us to our key innovation, which is multidimensional scaling. Now, in multidimensional scaling, I shouldn't click this. Next movie, please. Can we play the movie of the multidimensional scaling? Can we go on back? It's playing? Oh, I can't see it here. My apologies. Now I got to talk. I don't know where it is sitting. It's played everything. Okay. So you all saw, let me give you the background commentary, how originally in a scale-out distributed architecture, you had the queries hitting each one of these nodes because indexes and data were co-located. And indexes and data co-location basically meant that you had to hit each of these nodes and pick up the data from the indexes on each one of these and figure out where the data is, and then the query response. Imagine you had a 100-node cluster with a 1% error rate. That query, you don't know the validity of that at the end of the day. It could be really slow or it could be incomplete. Now, what we have done with 4.0 is introduce first workload isolation. The workload isolation basically means that you have the ability now to subcluster your Couchbase cluster into index services, query services, and data services. This itself is a huge advantage because now workloads do not impede each other. One could be compute intensive, one could be network intensive, one could be data intensive, or lookup intensive. So this isolation should give you already a performance boost. To that, now you can independently scale each one of these systems where you can add more nodes to your index cluster independent of how your data is. That's horizontally you can still scale the system. Now, what you can also get to is basically independently scale the hardware. That means you can actually take if your index nodes are having too many lookups within them, and that is causing a lot of scatter gather, if you will, you can actually scale the system up by actually getting a much more powerful hardware, which is, you can get a SMP box and co-locate all the indexes in one box, so there is no more of the scatter gather or looking across the network is happening. It's in one system. Your query goes to the index node, and the index goes to the different data nodes, and you get the data. So what you basically have is, so there's video there, something else. I'm just talking about the summary of how MDS is. So what you basically have is you can isolate the workloads. You can independently assign workloads to scale out different parts of the system. And finally, you can scale up or you can scale out. So that's the multi-dimensional scaling part of it, which gives you the ability to scale up or scale out. You've never had a system like this before. I've talked enough in terms of what all the great technology that we have built. Talk is good, but let's show you something which will impress you. So I'm going to bring Perry up on the stage to give us a live demonstration of how all these technologies come together. Welcome, Perry. Come on up to the stage.
Thanks, Ravi. Give me just a minute here.
While Perry sets up, let me just briefly give you a description of the application we built. The demo application is a travel reservation system. We picked that because it's got two good characteristics. One is that you need the application dynamism, where you want to change the application on the fly because your application either gets popular or gets more traffic. Which brings us to the second point, which is the traffic. If the traffic load peaks because it's coming close to a travel season, then you need to scale your system appropriate to that. So we have a demo that will basically showcase to you how you can actually model the data for the right application that you need to build, which gives you all the flexibility of the JSON and the query language that we talked about. And at the same time, how the Couchbase Server naturally scales so that you can now add more capacity because the travel season is upon us, and you need more. You have more traffic coming, and need to service more requests. So, Perry, did I talk enough to cover for all the setup you had to do?
I think I'm ready.
All right.
I hope I'm ready.
And that's
okay.
The live demo for you.
Thanks very much, Ravi. Thank you all for joining us today. We should have the slides on the screen. Looks like we do. Good. So we're going to be introducing the demo application. And this is a travel application that we decided to build. It has a reasonably complex data model and is somewhat representative of the performance and scale demands that our customers and you guys out there have. This is live and available now, so feel free to download it and give it a try. So let me first jump over to the demo itself and show you a little bit of what this looks like running live. So here is the login screen for the application. I'm going to put my name in here, some quick credentials, sign in, and do that one more time, because There we go. And here, a pretty traditional, simple flight search application. I can go from LAX to SFO. All of these are doing lookups in the background to Couchbase. Pick a date. I think we're going to fly over the 4th of July weekend, take a little holiday. Go from the 1st to the 8th, click Find Flights, and very quickly you get back a list of all the flights that are available. Now, this list may look reasonably simple and straightforward, but it was actually fairly complex to build, and that's what I want to talk about a little bit more. So if we can switch back to the slides. Here we have that list that I was building, and the slides aren't on my monitor. But if I click in and show that list, and we take a look specifically at one of the parts of building this list, the airline information coming on the left-hand side there, being mixed with and combined with the route information. So we've separated these into two different documents. Now, under a traditional model with Couchbase previously, to build this, you would first want to read in the root document. You'd have to identify that. Then you'd have to parse its JSON. Then you'd have to find the airline ID name. Then you'd have to go and read that airline document. Then you'd have to parse its JSON. Then you'd have to find the call sign ID. Finally, you can display this information back to the user, and you end up throwing away those two objects. But now, with Couchbase Server 4.0 and Nickel, we can do a join on the airline ID field, and in one query, be able to select the information from both of these documents and send it back to the user.
Fantastic. I think what Perry is basically showing is that how you can actually push the data tier concerns down to the database. The database can process, and so now the application is that much simpler to write. And it basically saves a lot of round trips between the application and the database, so you don't have to do all the application, the data tier logic processing in the application tier. So we have introduced, so to say, joins. Relationships are important, and we preserve that. And where it is not important, where it is extraneous, you can contain it within an object. And that's what this power of SQL that comes in, so that the data tier can handle the relationship building and the rest of the processing logic behind that.
Exactly, and it also abstracts the user, the developer, from having to worry about the schema underneath and whether that's going to change or not, and whether the versions are going to be a little bit different. Let's take a look at another part of this. If we go and look at the actual routes themselves and lists of the schedules, the route document contains all of the different flights for all of the different days for that particular route. And in order to pull out just the ones that we wanted to display to the user based upon the date that I searched on, in a normal programming model, again with Couchbase, you would have to read in that document for each of the documents. You're going to have to parse the JSON, find that schedule object, iterate over each one of the entries in there, whether it matches or doesn't match, dealing with all of the memory management and the schema versioning and all of that. Finally, you're able to send that back to the user with the list of airlines. You're combining all of this in a really complex application and a lot of logic in there. And again, you're just throwing away those objects that you read back from the Couchbase. But now, with Couchbase 4.0 and Nickel, we can do all of that in a single statement. And what Ravi was mentioning earlier, the unnest verb, the unnest word, allows us to unpack that schedule object within the database, identify just the fields and values that we're looking for, and return only that back to the user.
Fantastic. I think this is the nested recursion I was talking about, how you can actually introspect the JSON, get into the array or the list of objects that you have there, pull one of those, bring it as a top-level object, and now the rest of the SQL pipelining is applicable to that. I think that solves a lot of complex data processing at the data tier. So this is like a self-join happening within, and that is the power of how we bring SQL and JSON together.
Exactly, and it's a great example of a query and a data structure that you would be able to build with JSON, but otherwise be unable to query with standard SQL. And so the unnest, in addition to the standard SQL, allows us to very, very closely match the types of data structures that you can build with JSON because of the natural embedded hierarchy that it allows you to, but also query it with this programming language as well.
Fantastic, Perry. This gives us a pretty good sense of how you can data model and then do the processing at the data tier and keep the application simple. How about the other side of the equation, the scalability or the performance that you would need basically for this thing? If I were to look at the amount of data that is actually sitting inside, would you be able to show me something in terms of how we can introspect the data that is sitting in there?
Sure. Let's take a look at how the Couchbase server is running underneath first.
Sure.
And if we go back to the demo, good. We see here the same Couchbase cluster that you know and love, the cluster overview screen. We take a look at the server nodes here. I've got a handful of nodes. And in line with that multidimensional scaling, we have some nodes that are only handling the data service, some nodes that are responsible for the query service, some nodes that are responsible for the index service. And they're all built together within the same cluster. They're all the same node, and they can all be monitored and managed together. But we've been able to isolate the different workloads across them. If we take a look at one of the data buckets that I have here that's running, we're doing about 4 million operations per second, and this is primarily to the data nodes. You can see here a lot of that is reads, a little bit of writes, and then down below we've added a new statistic for the nickel queries that are going on. The queries going directly to the nodes that are part of the query service.
Fantastic. Now, 4th of July season is bonus, more travel. So you want to actually add more capacity. How easy or difficult is that?
So in the past, we would have had to just add nodes to the cluster, and everything would have scaled out together, spreading more of the indexes and more of the queries across. But now with 4.0, I can go in here, select to add a server, unclick the query service here, unselect data, click Add Server. Let me just add a second one.
Wait, so what you're talking about is you added more capacity to the query with just those 3 clicks?
Yeah, that's all you need to do with Couchbase Server now. I can, anytime I add a server, add a node, at runtime, I'm configuring which services it wants to be part of. So I can select to have all 3 of them for a relatively simple application where we still have everything distributed across all the nodes of the cluster, or at this point I can decide only to let this node be part of the query service, and it will only be responsible for handling requests in that part of the workload.
Fantastic. That sounds almost like magic to me.
So I'll click Add Server, do a rebalance here.
Engineers do all this work. I just stand here and talk.
The rebalance completes very, very quickly because we're not actually moving data around. We're just allowing the service to expand. If we go back into the events, we see that it's still running at the same 4 million operations per second. The data service hasn't been changed or touched. And we can see that the nickel queries are starting to go up slightly. If we now we're able to generate more load at it because that load is being distributed against 4 nodes in the query service as opposed to just 2.
Sure. Fantastic. So basically, what we got to see was that the data workload were not affected when you added more query workload to the system. It was still peaking at the 4 million ops per second that you were actually doing. And then when the query service came on, the extra load was taken by the query cluster that you provisioned for more.
Exactly.
Fantastic. That's very nice. And now, needless to say, I have to ask more questions of you since you have done such a great job of demonstrating how things come together. Now, one of the key things that you always want in a database is to be able to introspect that and get a sense of what is sitting in there. So would you be able to show me, you made a flight reservation from San Francisco to LAX to San Francisco. So how many flights are originating from San Francisco? If I were to ask you the question, how many flights go out of San Francisco? Is that kind of data something you can look in?
I think there's probably something I can show you here. So let me hop down into the command line.
Sure.
And I'm on one of the nodes in this Couchbase cluster.
Sure.
I'm going to run our query shell. CBQ stands for Couchbase Query. And you said you want to know how many flights are going from San Francisco, right?
Correct.
All right. So based upon the
That's
data
a trick
model
question.
there,
I'm asking to see if they have count capabilities.
I think I can do select a count star from flights where the destination equals San Francisco. There you
Wow.
go, 14,372 flights in our database.
Wow, and that was pretty responsive too. I mean, it shows like, what, 300 milliseconds for that query?
And that's using the index underneath, the secondary index. So it doesn't have to go to all the different nodes to find all of this information. It just makes one request to the node that has the index service on it.
Fantastic. And the second thing I noticed, having done SQL in my past life, you issued a standard SQL statement, and what came out doesn't look familiar to me. This is JSON.
That's a good point. So you know how SQL operates on rows and tables, and then it projects back to the user those same rows and tables in that same format. With Nickel, we operate on JSON, and now we project JSON back to you. And so everything you get back is a JSON object with the results, like we see here, with the number of flights, and with some of the metadata about how that request was accomplished.
Beautiful. Now, I'm getting greedy here, since I showed partner ecosystem and how Couchbase naturally plugs into stuff. Is that a better way, or is that a more visual way that this data could be represented if you can have more intelligence to it?
Yep, I think I might also have something to show you here. So if I hop over to a Tableau interface, oops, sorry about that, and choose this other databases, the ODBC driver there. I've set up a DSN underneath for Couchbase connected to my cluster. Connect that, say OK. Go in here, select the same Couchbase database that I want to operate off of. I can get a list of the buckets, choose the flight bucket, come over here, and I've done a little bit of preparation ahead of time, but now we can see the list of flights ordered by how many there are from San Francisco to any destination. We can see here that LAX and JFK by far have the most number of flights out of San Francisco.
Fantastic, and that gives you more insight into how your data is, and you can actually do a lot more visualization using tools like this.
Exactly.
Fantastic. The Couchbase data flows into the ecosystem and outcomes beautiful insights more than just visualization. Fantastic, Perry. Amazing. I put you on a spot on so many things, and you've come through. As the first time you're trying some of this stuff. Thank you.
Thank you, Ravi.
I appreciate it. So basically, what we sort of showed you out here was that how Nickel makes it easier to develop and how it makes it faster, the whole development cycle, right? Along with on the back end, the multidimensional scaling that we have added to the server backs up this query language to give you the blazingly fast performance that you really need. And that gives you the dynamic way of scaling your system. Either you can scale out or scale up. And so that basically is the whole idea of doing this, bringing the power of the sort of horizontally scalable systems and the flexibility of JSON to the structure and power of SQL that gives you all the benefits you would actually look for in a database system for you to have responsive applications in this web, mobile, and IoT applications, which is where the digital economy is moving. I talked a lot about the various technologies that were built here, and I also wanted to give you pointers to a few sessions which are substantive. This doesn't represent all the sections, all the great sessions we have, just some. These could be jump-off points for you to decide which are the other ones you want to go to. So introduction to Nickel, Gerald Sanguri's session is a phenomenal one. It'll talk to you about all the nested recursion I mentioned, all the SQL pipelining, and great stuff that is hidden underneath. So you get a better appreciation of what all has gone in here. It's been in development for almost 2 years, and a lot of engineers have done great work, and Gerald has been spearheading this. Absolutely a must session. The deep dive into secondary indexing, that's a deep one. John Liang knows databases, and he has been developing databases for a while, and his elegance of the solution is mesmerizing. Next generation storage engine by Chiong. Chiong is a beast. He understands storage engines to a level of depth that is scary. And out of that comes this great innovation. That session will give you all you need to know about hierarchical B+ tries. It's difficult to even pronounce, but he'll make it sound simple and easy for you. And there are also another session on SSD optimization that Professor Lee would be talking about, which will tell you how foundationally we are even influencing storage companies to actually change their APIs for better performance. There's a great session on Spark integration. With 3.0, we introduced what is called DCP, which is a database change protocol. It's an in-memory data exchange protocol. To that, we have added SQL. So this naturally plugs into the Spark SQL paradigm. So it's a very important session in terms of how the data within Couchbase can now work with Spark and the Hadoop ecosystem. Introduction to the Couchbase mobile. Wayne Carter is so passionate about mobile. You'll get to hear some phenomenal stuff out there, both in terms of how the Android and iOS Couchbase Lite, the details within that, as well as on the sync gateway and the various topologies that you'll typically deploy this. Some amazing stuff here. And last but not the least, a lot of you are here who have used Couchbase, and a lot of you are evaluating Couchbase. You always start to wonder, if I want to put mission-critical data in there, what about security? And Don Pinto, he has been thinking security, and he knows all those acronyms and the alphabet soup out there, and he can actually tell you how security is enhanced in every version of Couchbase Server, and especially the advancements we have made in this one, which is like LDAP integrations and auditing, some great capabilities we have added. These sessions are phenomenal, and not just these. There are so many others in the developer track, in the architecture track, some of the customer sessions. Very rarely will you get to see such technology and technical depth in a two-day sort of conference. So I encourage you to sort of avail of this opportunity to meet these great developers and the rest of the Couchbase team, which has put this thing together. And this is the excitement that I was talking to you about earlier. We are building a next-generation database for the digital economy. We built it in a very innovative way. We ask the tough questions. We make foundational innovations. These foundational innovations we make standing on the shoulders of giants, like we did for SQL. These innovations we make by looking at hardware trends, software trends, networking trends. These innovations we make by looking at the partner needs, at the customer needs. The Couchbase team, together with our partners, together with our customers, together will build a great next-generation database for the digital economy. Thanks.